was, number 9, why is my computer all askew? That's my question. Why is the value of negative 5 squared and then in brackets cubed negative? Carolyn, your hand was up first, so let's take it away here.
Yeah. So it's a power of a power, and you can multiply it, so like it's 2 times 3, and then it's in brackets negative 5 to the power of 6. But it's in brackets, so we can also just use the bracket away plus, yeah. And then in the base, it's just 5 and not negative 5 in the base, so it's negative 1 times 5.
Okay, so there we go. What we've got to recognize here, yes, that piece, that's where I want to start. So this piece, what we've got to recognize is that because it's negative 5 squared, there's no brackets between the negative 5 and the squaring. What we need to recognize is that the base here is actually what? 5. So this is going to be negative 1 times 5 squared. And that whole thing is then going to be cubed. Carolyn, continue from this point. So then I'm going to distribute the 3 in there. It's going to go onto the 5 squared, and it's going to go onto that negative 1. So I'm going to get this negative 1 here cubed, and then I'm going to get 5 to the power of 6. Because 2 times 3 is 6. Negative 1 cubed is negative 1 times negative 1, which is positive, but then I'm multiplying it by negative 1 again, making it negative. So it's going to be negative 1 times 5 to the 6. This is the reason right here that this whole thing is negative. Does that alleviate things? I'm seeing some big eyes and some scary eyebrows. So have I made things worse? Or do we feel okay about this? I'm seeing some nodding heads. I'm seeing some heads nodding from the person who asked the question, so that's good too. Because considering our previous work, we should first times the 2 by the... Oh, so the email says we should times the 2 by the 3. While that's true, yes, it's also that negative is what... So the person said, yeah, we're going to multiply the 2 by the 3. That's true. But the 2 isn't on the negative. The 2 is just on the 5. So I have to treat that negative 1 separately. That was the only question. Can you all nod if that makes sense? So this is why. Because the base is 5, not negative 5, so the squared is only on 5. And then that negative 1 is to an odd exponent, which is going to give me negative 1 times negative 1 times negative 1, which is negative 1. Because I have an odd number of negatives. But it's not negative 5 to the power of 6. It's 5 to the power of 6 times negative 1 to the power of 3. Because there's no... Jennifer and Sukjap, do I have to create a seating plan to move you two apart? Yes. Danny.
So if we were actually to do 5 to the power of 6, or, yeah, is that the final, no, what's the final?
The question says why is this negative? This is the reason.
That's the reason.
That it's negative.
But if this was an actual question,
yeah.
But could we do 5 squared and then cube it? Like have, but then you would just kind of ignore the negative and bring it back. Negative 25 cubed.
Sure.
And then you'd get the same answer as if you did 5 to the power of 6. Or negative 5 to the power of 6.
Maybe? I'm not sure I understand the question.
Like if you did...
So if I just said, what is this? Like evaluate this? Is that what you're asking?
Like if you evaluated it and then you cubed it.
5 squared and then cubed. So, but if the question just said evaluate this whole expression, is that what you're asking?
Yeah.
Okay. So, I mean, I would march it through like this, and then I would shove 5 to the 6 in my calculator. I mean, unless you know what 25 cubed is, but I don't.
Would it be the same thing? Maybe actually you have to, yeah.
I want to say yes.
Can I calculate
Sure. Show me your calculator, see what you get.
It's the same thing. It is? Okay.
It should be.
Yeah, it should be.
Because I'm just applying totally valid exponent laws.
Right.
So,
Okay.
were there any other questions out of the homework anyone wants me to take a look at? There was a lot that I gave you. 16 ACE, 17 ACE, 19 ACE. With which one? 15C? E. 15E. Kate, you guys at the back, stop talking so loudly. What are you guys doing? Did you figure it out though, Angel?
Yeah, I figured it out.
Okay.
I wasn't doing that one. It was something else.
Okay. For what? Either one. Typically, the Learn 34, like they both go to straight to my phone.
Oh.
I will respond to either of them. Typically, students use my Learn 34 email though. Are you emailing me right now? I don't know. We'll never know. Okay. What other questions does people want to look at for the homework? That's actually really smart. If you guys want to ask, oh, I like that. No one's ever done that before. I like it. I won't tell you. I'll tell you later. I just had a brilliant idea. Any other questions from the homework?
What's a brilliant idea?
I'm not going to tell you. My brilliant idea. So there's nothing, no other questions from the homework? Going once, twice, thrice. Sold. Okay, cool. I'm hearing nothing. So through that. We all did the homework, yes? It's always a little bit scary when there's especially about things where you guys were like complaining to no end about these questions here and like how to do them, and then the next day there's like no questions at all. It always makes me a little uncomfortable, but I'll see, and I will find out tomorrow whether or not there should have been questions today. Hint, hint. I'm just going to say that. I'm just going to toss that out. I'm going to find out tomorrow if there should have been questions today. Hint, hint. Okay, let's move on to today's lesson, shall we? If you can't figure out what I'm trying to say, you'll find out tomorrow. Or ask anyone who's freaking out right now about what I meant. Yeah, Kyla. Who wants to go for a walk? Okay, Kyla. Yes. So, okay, ladies and gentlemen, I would like to jump into this. Do you actually want to go for a walk? Well, I'm going to start a lesson. Do you think it's a good idea for you to miss that? No. Then I probably wouldn't go anywhere. Also, your mask should cover your nose. Okay, here we go. Lesson 6, powers of zero. I need y'all to stop talking so we can move on here. Yes, Carolyn? Oh, you're answering my question. You're answering the question? Is that what you're doing? Okay, so here we go. I've already showed you that I showed you what this law is. We actually talked about it on the very first day. Anything to the power of 0 is 1. But you've got to make sure that the thing you're dealing with is actually to the power of 0. Does anyone need me to reprove why that's true? Because when you divide backwards, it reduces the exponent, and eventually you're going to get to the spot where you divide the number by itself and reduce the exponent from 1 to 0. Anything divided by itself is 1. And then when you reduce the exponent, it gives you the 0, so that anything to the power of 0 is 1. I showed you that on the very first day of this chapter. Examples being this. So let's just rattle this off. 10 to the 0 is? 1,324 to the power of 0 is? X, y in brackets to the power of 0 is? Negative 6 to the power of 0 is? Boom, I tried to trick you, but Presley said it first. This is negative. Why is this negative 1? Because what's the base? 6, not negative 6. So that the 6 to the 0 is 1, and then I multiply the negative n. I tried to trick you, but of course there was 2 of you I couldn't trick, and the rest of you didn't say anything. The last one, if it's in brackets negative 6 contained to the power of 0, that's going to be 1. Cool?
Wait, but on the other one with brackets, you said that 6 is the base.
Without the brackets, 6 is the base.
On the other,
With the brackets, the base is negative 6.
you just said on the other side of that bracket. Okay. Where, I can't find it. That one's inside the bracket. Oh yeah, okay. Okay.
You answered your own question?
Yep.
Fantastic. Okay, so negative exponents. Negative exponents are relatively easy to deal with. They follow just like what happened before. So the proof that I gave you for the power of 0 is the same proof that I'm going to give you here, except typically students are like, oh yeah, okay, cool, I'm fine with the fact that anything with the power of 0 is 1, but then as soon as negatives get involved, you all start, sweating blood and crying a little bit. So I'm going to try and prove this to you, and we'll see if it makes sense. So I'm going to start on the right-hand side. No, I'm not. Yes, I am. Yes, I am. I've got 3 squared. If I divide this by 3, what do I get? No, no, no. No, no, no. Don't 9 divided by 3 me. What's happening? I've got 3 squared. I showed you this on the very first day, so think back to that first day. When I take a number to a power and I divide it by the base, what's it going to do to the exponent? It drops it down by 1. So 3 squared divided by 3 is going to give me 3 to the power of 1. Right?
So why can't it just be?
For reasons that are going to make sense here in a sec, I don't want to write 9. Fine, I'll write 9, but I'm putting it below. So 3 squared is 9. 3 to the 1 is going to be 3. To jump down this way, 9 divided by 3 is 3. It also knocks the exponent down 1. Yes?
So, but it is just 3.
No, I haven't got to my point yet.
Okay.
No, I'm not at the point yet. This is what we've done this already. This was day 1. Yeah?
So you square 3, and then you divide it by 3, and then you,
What
off
up?
1?
It,
Just 1?
when I divide once, it knocks the exponent down 1.
What if you divided it more than 1 time? Would you not?
So like if I divided it again, it's going to drop my exponent down again, and that's just going to be 1.
Or no?
Well, see, Danny, that's my question that I'm going to ask you now.
Oh.
What happens if I divide by 3 again? I'm going to decrease my exponent by 1, so that's going to give me 3 to the negative 1. But what's that going to be down here? See, but I don't like that. I want you to write it as a fraction, for reasons that will become more obvious here in a second. 1 divided by 3 is going to be 1 over 3, yes? So dividing by 3 on this orange line knocks my exponent down by 1. Dividing by 3 on this blue line down here at the bottom, 9 divided by 3 was 3. 3 divided by 3 was 1. 1 divided by 3 is just the fraction 1 over 3. Yes? Are we cool with that? Not if we're okay with this. Lots of people not nodding. We cool back there? Is this making sense? Okay. Let's go again. Yes, Carolyn. We'll get there. Don't say anything. We'll get there. What happens if I divide by 3 again? Hold on. Kyla, you have something you want to say. You mean here or here? We're going to do both. Which one do you want to give me? Presley? Okay, so you're doing the blue one. Okay, if I have 1 over 3, and I'm going to divide that by 3. Okay, I'll show you over here what that looks like. 1/3 divided by 3. This is the same thing as 1/3 times 1/3. So it's going to give me 1 over 9. Okay? But I can rewrite 9. How can I write 9 as a base 3? How can I rewrite 9 with a base of 3? Rebecca. 9 is 3 squared. So this is the same thing as 1 over 3 squared. What's that going to look like on this orange line here? 3 to the power of -2. So are we seeing what's happening here? Not really. I appreciate the honesty. What I want you to see here is this relationship right here and this relationship right here. What do you mean? What if what was 4 squared? Does it matter what my base is? Is that the question? Would it make sense that it would work for 3 and not 4? Like, so, I mean, that you might not think that that's a good question. That's actually a really good question. And it's actually the most irritating question you're ever going to have to answer, assuming you go on and do a full-on degree in mathematics. There will be whole courses about, does this actually work everywhere? That's a really good question.
So then I could have done 1 over 16 and it equals to 1 over
4
4
over 4 squared. So, yeah. There are whole areas of mathematics that are devoted to proving that things like this are true everywhere. So, I mean, we could do it again. If I had something like this, if I had x squared, and I divide that thing by x, that's going to give me x to the 1, right? It doesn't really matter, right? I'm just dividing by x. If I have x to the 1 and I divide by x again, that's going to give me x to the 0.
Well, when do you stop?
Do you ever have to stop? What if I divide by x again? Well, we can see the pattern here. Well, this is going to give me x to the -1. Divide, if I have a base to a power and I keep dividing by that base, it just knocks the exponent down. Tick, 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 tick. And there's no reason why. I mean, I don't know what the value, I don't know what x is. But I'm allowed to divide by any number I want, except for what number? 0. So as long as x isn't 0, this is totally valid. I can just keep doing this. But looking at what we looked at down here, we have a relationship here that exists. X to the negative 1. Well, if I write this here, I'll show you another way that this looks like. Well, another way to represent this. If I have x squared, division by x is the same thing as writing it like this, right? X squared over x. But x without a power is written as, if there's no power here, what is the assumed power? It's 1. What do I do when I have x squared divided by x? What do I do with these two powers? When I multiply, I add. When I divide, I subtract. So it's 2 minus 1. It's 1. Okay, so let's divide by x again. 1 minus 1 is 0. Okay, cool. Let's divide by x again. 0 minus 1 is negative 1. But x to the 0 is 1. So then this thing is just going to be 1 over x. Because I had this here is just 1. And then I divided it by x. 1 over x is just 1 over x. Or I could write it as x to the negative 1. Both of these are true. And it doesn't matter what the value for x is as long as x is not 0.
Can x be a decimal?
As long as x is not 0.
Okay.
Literally any other number, it's because 0 is the only thing I'm allowed to divide by.
Right. But you can't.
No, you cannot divide by 0. It's undefined. Okay. So what I'm trying to get you to see here is this relationship that exists, because it's going to be we look for these relationships to allow us to find shortcuts. So if I have x to the power of negative n, I'll zoom this in here so it's easier to see. X to the power of negative n is going to equal what? What's the shortcut? Carolyn? 1 over x to the power of n. So to think about what that means here, x to the negative n, I can take my base, I take the reciprocal of it, and it makes the exponent positive. Kind of cool. So let's see how that works. I give you a couple examples here so we can just talk it through. 2 to the negative 3 is equal to 1 over 2 cubed using our shortcut. And then I can just evaluate 2 cubed to give me an eighth. Yeah, you can see what, I mean, look at what happened here. 3 squared was 9. Okay, that's cool. 3 to the 1 was 3. Yeah, okay, cool. Divided by 3. 3 to the 0 is 1. This we did on the very first day. But then I take this and I divide by 3. Well, 1 divided by 3 is just going to be 1 over 3. But I could also look at it this way. When I divide by 3, I knock the exponent down. So that's going to become 3 to the negative 1. I could write it in here, maybe make this more obvious. 3 is just 3 to the 1. So 3 to the negative 1 is equal to 1 over 3 to the positive 1. By flipping it, it makes the exponent positive. Does that answer the question that was just asked? I think that was Harmon's voice, yeah? Okay. Can I do the next one before you ask that question, Danny? Or is the question about what I just said here?
It's a question about, like, the example.
This one or this one?
The other one.
Okay.
Or I guess it doesn't matter, either one.
It does matter.
So you take the first thing and you put it over 1?
Yeah, I take the reciprocal and I flip it. Because right now this is 2 to the negative 3 over 1.
Oh, but you flip it.
So then I flip it.
Oh, okay.
It was in the numerator, now it's in the denominator,
And then you
and my exponent becomes positive.
So the point of that is to find what? Okay.
The point of this is to leave our problems with only positive exponents.
Okay. So you just do whatever you have to do to make it positive?
Because conventionally, at the end of all things, we want to have only positive exponents.
Right.
Okay, let's take a look at another one. What if the thing was in the denominator? So let's take a look at that here. I'm going to write this next to it. I have 1 over 3 to the negative 4. Well, I don't want the negative exponent. I only want positive exponents. So to take 3 to the negative 4, and I want to make that negative exponent, I want to make it a positive exponent. What I'm going to do is I'm going to do what I did over here. I'm going to take my base, 3. I'm going to take the reciprocal of it, and it's going to make the exponent positive. Well, it's going to go on top. It's going to become 3 to the 4 over 1, which I just write as 3 to the 4. And it's only the base that does the moving. I'm just going to shove another example here on the side. What if I have something like this? What do you think is going to happen with that? Kyla. Say that again. So you're just making that thing positive? How did you make that exponent positive? There's a procedure you have to go through to make that exponent positive. So here's the question. What here is the base? The base is x. So nothing, so what I'm hearing of some murmurs from this front corner here is nothing is going to happen to that coefficient because the exponent doesn't apply to it. And then the x to the negative 2 is going to become 1 over x squared, which is going to give me what? 2 over x squared. What I want you to be able to do is go straight from here to here. Should we do another one? Okay, what if I had, do I have a bunch down there? No, I don't have any down there. What if I had 2x to the negative 3 y squared over z to the negative 4. Now it's getting a little bit more complicated. But because each variable here is different, like I don't have multiple x's or y's, we're just going to deal with them all separately. Is anything going to happen to this too? No. So in my fraction, I'm just going to have the 2 there. X to the negative 3. I wanted a positive exponent on this x. So what do I have to do to x to the negative 3 to get it to have a positive exponent? Which is going to do what in this fraction? No, what is ultimately going to happen? You're right, it's going to become 1 over x to the positive 3. But what is that going to do? What happened here? To make my exponent positive, I just dropped it to the denominator. So this is just, I don't want to do the intermediate step. I want you guys to get comfortable without doing that intermediate step because it's going to make your work look like nasty. So we're going to make it x to the power of positive 3 and we're going to drop it to the denominator. So yeah, because I've got a negative exponent in the bottom, I'm just going to move that up to the numerator. So it's going to become z to the power of positive 4. And then y was already a positive exponent, so it just stays where it is.
So why isn't y squared before the z?
Because Harwin talked about z first.
But it could be the other way?
Yeah, it doesn't matter. I could have 2y squared z to the 4. You can multiply in whatever order you want. It doesn't matter what order you write these things in.
So you take the negatives and you put them in the, or you just put them in the opposite. You switch them.
Yeah, you take the reciprocal. If it was in the denominator, it moves to the numerator. If it was in the numerator, it moves to the denominator. And when you flip it, the exponent changes sign.
Right. So I don't understand. We explained, or you explained the example
Yeah.
So, why, I still don't understand why it works. Like, not that part, but how it all relates. I understand how to get the answer, but I don't understand why it works. Really.
So you're cool with everything I did up here?
Yeah. I'm cool with the...
And you're cool with my reasoning here?
Together, it's confusing.
So where did you start to get uncomfortable? Here or here?
Like up there.
Here?
And then
or here?
That. But once people started doing it, it made sense. Like, you just flip it, and it becomes a positive. And you leave the positive ones in their place.
Yes.
But I just don't totally know why that works.
Because of so what I tried to do with this particular law is I tried to build a bunch of things that you guys were all able to say, yes, I can accept this.
Yeah.
So you were able to accept that dividing by the base lowers my exponent. So I can just keep making negative exponents. 3 to the 0, 3 to the negative 1, 3 to the negative 2. I just keep going here. You guys are like, yeah, that's fine. Here, I was able to show you that dividing by 3 just divides by 3. 9 divided by 3 was 3. 3 divided by 3 is 1. 1 divided by 3 is 1 over 3. 1 over 3 divided by 3, I showed you how it was 1 over 9, but I can write 9 as 3 squared. So 1 over 3 divided by 3 is just 3 squared. And then what I wanted you to see was, well, that must mean there is a relationship here between 3 to the negative 2 and 1 over 3 to the positive 2. And the relationship that exists, the shortcut then that exists, if this is true, and it is because there was no illegal math going on here, this must be true.
Oh, wait. So it's just flipped. Like,
Vertically, reciprocal.
like 3 squared over there is 3 negative squared, but then the 1 over 9 over 1.
Yeah,
Oh, okay.
that helped?
Mm-hmm.
Okay, I got one more I want to do. No, that's not true. I don't want. We're going to do some of these ones down here. These ones are going to be simpler than these ones. Okay, so I've got 4 to the negative 1. What's that going to be? It's going to be what's 1 over 4. Well, someone said it was. It's not obvious why that is? Oh, fair enough. So let's look back at our rule. X to the negative n is equal to 1 over x to the n. So if it was in the numerator, like this is just the same as x to the negative n over 1, right? I'm allowed to put things over 1. We cool with that? So I just take the reciprocal of it, I flip it, and the exponent becomes positive for all of the reasons. Like this is my proof of why that works. So my exponent here was negative 1. So this is, to make that negative 1 positive 1, I'm going to flip it. So the 4 is going to become 1 over 4, and the exponent becomes positive 1. When I have an exponent of positive 1, I don't write the exponent. This is just going to give me 1 over 4. Did that help at all?
Yeah.
Gentleman in the back corner? You did it different. Did you get the same answer I got? Okay. What's the next one then? 1 over 3 squared. Good. This is just going to be 2 squared. Very good. I see that hand. Is now a great time to do that, or can you hold off for like 2 more minutes? Because this single page is the lesson, and then I'm done. Yes, sir. For the sake of this lesson, all I'm doing is simplifying. I'm not evaluating. When the instructions say simplify and then evaluate, you'd show me this, and then you write this as 1 over 9. Well, then you just leave it as 1 over 3 squared. I mean, if you wrote it as, yeah. No, not necessarily. See, the really gross part here, that's a hard question to answer because I'm not going to give you, like, these kinds of questions, 3 to the negative 2, 1 over 9 is the correct answer. And that shows me that you flipped it and squared it. So, yeah, I'm okay with that. This is not the kinds of questions that you're going to see. These are the kinds of questions that you're going to see. And when I give you stuff like this, we always evaluate the coefficient piece.
Is that what's happening very, very soon?
It's possible. It's possible.
Or what we learned in the past few days?
All of it. You get 24 hours. Actually, that's less, you get less than 24 hours because I have you first block tomorrow. Or I could move it to quiz to Monday. We'll see how it goes. I'll think about it. Depends how you guys are for the rest of this block and tomorrow. Well, if you're showing me that you're trying to use this time well, I'll have mercy. But if you're screwing around, then I have no mercy. No, just this unit. Okay, so what do I do with this? Harwin. So what you're asking is this 1 over 4 squared? Technically that's correct, but now I'm dividing by a fraction and we don't like that. How do you divide when you divide by a fraction? What do you do instead? Instead of dividing by a fraction, you multiply by the. So this is just going to become 1 times 4 over 1 squared. But multiplying and dividing by 1, does that do anything? Oh, so it's just going to give me 4 squared. So what did I do? I just flipped the whole fraction. If I have a thing inside brackets negative to the power of negative 2, I can flip the whole thing. So like if this was, write this down, if this was 3 over 4 to the negative 2, there's a couple exponent laws here at work. If I have a fraction to an exponent, that exponent gets applied to the denominator and to the numerator. So I could think of it like, it goes there and it goes there, so that's going to be 3 to the negative 2 and 4 to the negative 2, which if I have 3 to the negative 2, where's that going to go? It's going to go to the bottom and become 3 squared. What's going to happen to the 4 to the negative 2 on the bottom? It's going to go to the numerator and it's going to become positive. So that's it. I could have done it in one step, yeah. If you see that, do it in one step. What? Yeah? No, it's just 16 over 9. It doesn't reduce. Oh, yeah. I prefer not mixed fractions, honestly. Mixed fractions are good when you actually have to understand what the amounts mean. Improper fractions are better for you to show me that you understand the mathematics of what's going on. So if you need to understand your answer, mixed numbers. Like, I will never bake cookies and have 7 halves of a cup. I need 7 over 2 cups. Well, that sucks. Why not just write down 3.5 cups? When I need to understand what the value represents, mixed numbers all the way. But to show me you understand the mathematics, improper fractions are better. Okay, Kyla. Okay. We'll get there. Let's just rattle these off really quick. 3 to the negative 1, hands up. Emina.
1 over 3 to the power of 1.
Correct, which I don't have to write the power of 1. I just write it as 1 over 3. Love it. Who wants to do the next one? Yeah, 10 meet. going to become 3 cubed. Love it. Next one. Someone new. Sorry, someone's confused? Okay. I flipped the fraction. Angel, next one. And careful, we want to make sure that thing's in brackets. Yeah, you betcha. That is a totally acceptable answer. Flip the fraction, the exponent becomes positive. I could write it as 3 squared over 2 squared. That's the same thing. Next one. Carolyn. It's just 6. Love it. Next one. Someone new. I'll just start randomly choosing names off my attendance list if we don't get some volunteers here. And what's better, volunteering for something you know is coming or just getting randomly chosen? Presley.
5 squared over 2.
I thank you for being brave, but you are incorrect. Why? What doesn't move? The 2. The 2 in the numerator, it does not have an exponent on it. It doesn't move. So Presley, what should it be?
2 times 5 squared.
You betcha. 2 times 5 squared. I love it. I'll always give you an opportunity to fix it. Love it.
Wait, but why? Can you explain that?
This one? Okay, so this one is just like what I did here. The base here, the thing that had the exponent on it, is just the x. So the x is the only thing that moved. The coefficient stayed where it was. I flipped just the base, and then I got 2 over x squared. So this one is actually just that same question, but in reverse. The base here is the 5 in the denominator. It has a 5 to the power of negative 2. So it's this piece is the only piece that does any moving, and the 2 stays in the numerator. The 5 to the negative 2 flips to the numerator and becomes 5 squared, and the 2 stays where it was. Because it was already in the numerator, the 5 squared joins it in the numerator. So this would be a totally acceptable way to write this. Well, the only other thing would be, because I know someone's going to ask it, well, if I evaluated that, is that just going to be 50? The answer is yes, because 5 squared is 25, and then I multiply that by 2. 25 times 2 is 50. But I'm not asking you to evaluate, I just want you to simplify it, writing it with positive exponents. What's going on with this beast here? This is the one that Kyla had a question about. So I said when we flip things, what becomes positive? The exponent becomes positive. So yes, the negative exponent becomes positive. So did I say anything about a negative base? No. So if you have a negative base, nothing happens. It stays negative. Sorry, say it again. Carolyn, give us an answer.
Is it just 1 over negative 2?
Yes, which I think is what Amy was trying to say at the end. Yes, that is correct. So then, what do I do with something like this? Somebody new. The sooner you volunteer, the easier the questions are. If you wait to volunteer to the end, you get the grosser ones. What's the base here? Someone be brave, who I've not heard from yet. Rebecca. The base is 2. Not negative 2, it's just 2. So what happens to this thing? It's going to become negative 1 over 2 cubed, you betcha. Thank you, Rebecca. Sorry? Use your words, but use them better. So you're looking at this question? The base here is 2. Because the negative was included in the brackets and the exponent was outside the brackets. Yeah. Yeah. ultimately, these two are going to give me the same value because this negative base has an odd exponent. So this is going to give me negative 1/8. This is also going to give me negative 1/8. But if these two had even exponents, they would give me different answers. This would be negative 1/16, and this one would be positive 1/16 if it was negative 4 here and negative 4 here. Danny.
So, if there were brackets on the bottom left one, where would those brackets be?
Well, it depends on where you put them that changes the answer.
But if it was the exact same, if it meant the same thing, where would you put brackets? When you put it, like, in the
If it meant the same thing as what?
as what's written there, like if you had negative,
Like you do this.
okay, that's what I thought. That answers my question.
There. Yeah. Kyla. Okay, because Kyla's in the front and she talks rather softly, maybe you didn't hear, but we're moving on to the next one. So Kyla, your question is what?
What's the answer to negative 1 over negative 5 to the power 2, or would the 1 and 5 cancel out?
Bed mass matters. So the first thing you got to deal with is the exponents. So that negative out front, the exponent is not on it, it stays where it is. So that's going to leave me a negative 1 in the numerator. And that negative 5 to the negative 2 is going to drop to the denominator, and it's going to become negative 5 squared. I thought you were going to ask me about this one. Because your question, Harwin, actually it's you and Danny always ask the question, you alternate. If I evaluated this, what would I get? Which is the question that I wanted to ask you guys. That would be negative 1 over 25. So Kyla, this actually goes back to the question and the reason I was hoping that was the question you were asking, Harwin, is because it's important to recognize, Kyla, that the negatives cannot cancel here first. Because if they canceled here, I would get positive 1 over 25, which is a different value. You got to apply the exponent laws first, evaluate the exponents, and then multiply or divide any negatives afterwards. Danny.
So, you're taking the negative 5,
Yeah.
and you're first, but are you just taking that whole thing and summing it over 1? But where's that negative?
This, when I have a negative out front, this is the same thing as multiplying by negative 1. So that negative 1 is just going to get left in the numerator. Because this...
Negative 1 times negative 5
to the power of negative 2, yes.
power of negative 2.
Yes. That's what this means.
You just ignore it because it doesn't do anything?
I am ignoring it because the exponent isn't applicable to it. The exponent, because there's brackets here, the exponent is just on the negative 5. So that I leave the negative 1 in the numerator, and I drop my negative 5 to the negative 2 to the denominator.
Right, you flip it.
Yeah. Yeah. Okay. Oh. Kyla? Is it still about this one? Okay. Can I do the last one? Oh, Harwin. About the next one. Okay, so let's move to the next one. Harwin, you have a question before we do it.
You know how when we were dividing, like before, we could subtract the exponent?
Only if the bases were the same. So right now, as it's written, those bases are not the same. One's 2, one's 4. Danny.
Can you still do 3 minus 2?
Only if the bases are the same, and they're not.
Oh, okay, that's what you just said. Okay.
Yeah.
But would you, like if you flip this, because they're both negative, would they just both be positive then too? Could you flip it?
When I flip it, it's going to become so what's it going to be then, Danny?
4 to the power 2 over 2 to the power 3.
You betcha. That's it.
That's it?
That's it.
And then you would evaluate it?
If I asked you to evaluate it, 4 squared is 16 and 2 cubed is 8, so that's just going to give me 2.
Right.
Which there's actually a little sneaky thing I can do here. Does anyone want to see the sneaky thing? Okay, let's show you the sneaky thing. 4. Can 4 be written as a number with a base 2? No, can 4 be written as 2 to some exponent? Yeah, 4 can be written as 2 to the 2. So I can actually replace the 4 here with 2 squared. So what that's going to look like is, in brackets, I'm going to have 4 becomes 2 squared. Then that becomes squared because it was 4 squared. I just replaced 4 with 2 squared. And then this is just going to be 2 cubed. Stays on the bottom. So then what happens here? Yeah, when I have a power to a power, what do I do with the exponents? I multiply them. 2 times 2 is? So this is going to become 2 to the power of 4 over 2 to the power of 3. And when I'm dividing here, what do I do with exponents? So I subtract them. It's always top minus bottom. So 4 minus 3 is? I heard a lot of O's. I didn't hear a lot of answers. 4 minus 3 is? 1. But 2 to the 1 is just 2. I just want you to I want you to see that that's the same thing. Danny.
Is it just the same that, like, you just 4 to the power of 2, you just flip and make 2 to the power of 4? But does that just work for that? That was my...
Okay, guys, whoa. Everyone stop. Everyone stop talking. The more I have to stop you guys, the longer this all takes, the less time you have to actually practice this stuff. Danny, what's your question? I know there's 6 minutes left. Let me keep going.
Yeah. Like, it was 4 to the power of 2,
Yeah.
and then it just became 2 to the power of 4. Is that just a coincidence, or is that actually...
It just is a quirk of the numbers.
Okay.
I could have done 9 squared, which would have become 3 squared, which would have become 3 to the 4, not 3 to the 9. Like, it's just a quirk of the numbers. That's a good question.
So I can do that in the future, because 2 to the power of 4 is the same thing as 4 to the power of 2.
Do not ever think about it that way.
Okay, but I could...
No, do not, because that's going to screw you up everywhere else.
Okay.
Just forget that you even thought that that was a thing. Because I guarantee you that's going to screw you over somewhere else.
Yeah. Okay.
Even though it's technically correct.
Okay.
In this case, technically correct is the worst kind of correct.
Like if somebody just said, oh, what's the same thing as...
But it's never going to happen, and don't think about it that way. Harwin.
You know when you like change the question, like how the 2 to the negative 3 is in the numerator right now?
Yeah.
When you change it to the denominator, doesn't that change like the whole value in the answer?
No, they're the same. That equal sign means they're the same. Daisy and Amalika, I gave Mr. Wright's one, should be the top one. Resource room. And they asked if the food could get here at like 11:15 so they can pick it up before the crazy rush so that their kids can...
We're gonna have it set up before lunch break.
Perfect. And their money is just going to get transferred straight into our account. Harwin, because every single step here has already been justified as being mathematically valid, no, it doesn't change anything. You betcha. Everything's going to be on the quiz. As long as it will be. It will be what it will be. No. Flip the page. Here's your homework. Oh, if it's your birthday, you should definitely have a math quiz. What could be better than a math quiz? Okay. Sorry that took longer than 2 minutes. Those of you who wanted to go for a walk and had to use the bathroom or get a drink, I hope you haven't died or ruptured a bladder. This is your homework, this page right here. I have decided, what do you mean all of it? Yes, all of it. There's hardly anything there. I have decided your quiz will not be tomorrow. Your quiz will be Monday. Tomorrow is going to be an exercise in applying all the laws to some really nasty looking questions. This is your homework. Get it done.
about the last question? Because I'm not sure that
This should never have negative exponents in your final answer. So this is a good first step. This is all true. Well, so you wouldn't also, like d to the 0, you wouldn't write d to the 0. Your final answer should only have a 1. Because d to the 0 is 1. So we would use that exponent law to get rid of that. And then c to the negative 5 would become c to the positive 5 in the denominator. So your final answer to that question
But I'm
should...
not allowed to write a fraction.
Yeah, you are.
I'm right without a fraction.
Oh, guys, Carolyn has found a mistake in what I've written. I don't, it's, yeah, here. Where it says, last one, I shouldn't say simplify and write without a fraction. I don't want you to write it without a fraction. I want without negative exponents. That's what I want. Change the instructions on that last question. Simplify and write without negative exponents. My bad. That was a mistake.
Okay, so the first was always right and I just...
Without a fraction, that's correct. Yeah. Fractions are great. Negative exponents are the thing that's gross. Did that help? Did I answer your question at the beginning of class?
Oh yeah.
You emailed me. And were you trying to email me a question? You have no reception here. Okay. Hold that thought. I need to stop the video.